So dear students, this is the continuation of the lecture number 3. Okay, so here to understand the sign of the loads to calculate the shear force, so we have taken the simply supported beam, okay, in figure number 29. So I have taken, this is the left hand, this is the right hand. Okay, so we will start from left hand to right hand to calculate the shear force. Okay, so here we are not going to calculate the value of the shear force, just I want to see the sign convention of the forces. Okay, so this will be covered later when we will be drawing shear force diagram. Okay, so here there are three distinct points A, B and C. So from A to point B, so there is a downward load, that is the UDL, uniformly distributed load. Okay, so here by this spiral uh, type, this load is shown, and at point B there is a downward point load. Okay, so we can calculate the shear force because it is not that tough. So to calculate the shear force at a particular section, so first we will be considering one section. Okay, so let's say at this point if you are asked to find out the shear force, so we will just consider one arbitrary section xx at a distance x from the initial point, that is x equals to 0 from the left hand side. So from here to here the distance is x. So up to this section, so whatever be the forces, so if you add up all the vertical forces by the definition of the shear force, so you will get the total shear force value. So here the shear force will be, so from left hand side if you will move to the right hand side, so you need to consider all the upward load as positive, so this load as positive load, then this is downward load, so you need to consider this as negative, then this is one downward load, then you need to consider this point load as negative. Okay, so by this sign convention, so like this way, so you will be calculating the shear force and you will be selecting the sign convention. Okay, signs of the forces. So here I have taken another example in figure number 31. So this is a simply supported beam. So here you can see this is point A, point B, point C and point D. So in between point C and point D there is a UDL of intensity W, you can say Newton per meter or per unit length. Okay, and at point B, so there is a uh, point load. So you may be asked to find out the shear force at point B or at point C or at point D. So you need to calculate it. Okay, so you need to remember that always shear forces are calculated at a particular point or a particular section, okay, or a particular plane. Okay, so because we have seen the definition of a of the forces that the beams are in static equilibrium, so all the shear forces and bending moments are calculated at a particular section only. Okay, so here if you ask to calculate the shear force, okay, at this point, okay, so you need to consider one section. So here I have taken the right hand as x equals to 0. So you can start from anywhere, from the left hand side or from the right hand side, no problem, but you have to obey the sign convention properly, that is the thing. Okay, so here from right hand side to the left hand side we are going or moving, so that is why all the forces which will be acting downward direction, so they will be positive forces, so these will be positive forces, and all the forces which will be acting from the downside, that is the upward forces, will be taken as negative. Okay, so to uh, calculate the shear forces, so we will follow this sign convention. Now next come to the second term, that is bending moment. Okay, so what will be the sign convention of the bending moment, okay, on a beam? So moment means basically what? So it is force into distance, means this moment will try to create a rotation, okay, probable rotation. So if on a beam, So the moments are acting, okay, and by these moments the beam is probable to bend in this fashion. So you can assume that the moments will be acting in this direction, then only a straight beam can become so this type, isn't it? So from both the side, so if I will apply this type of moment, so then it will be having this kind of shape. Okay, so this moment will be of clockwise nature and this moment will be of the anti-clockwise nature. Okay, the beam will be having two ends, one left hand and another is right hand. Okay, and this condition, okay, this condition is called as sagging condition. Okay, sagging, S-A-G-G-I-N-G, and this condition of the beam, okay, so due to some moments on the beam, so the beam may get bent in this fashion. Okay, so this is called as hogging. Okay, H-O-G-G-I-N-G, hogging condition. So in sagging condition, okay, so if you move from left to right, all the clockwise movements you need to consider as positive and all the anti-clockwise movements you need to consider as negative. Understood? So this is left hand, this is right hand. So you are moving from left to right to calculate bending moment, okay, on a particular section. Then all the moments, okay, so which comes under this section, suppose at this section, so you need to find out the bending moment. Then from here if you are moving, then the moments which will be there in this portion you need to just sum it up, then you will get the moment at this section. Okay, no need to sum up the moments which are there on this end, because from this end by definition the summation of moments up to a section is the bending moment, okay, by definition. So from left to right if you start, then all the clockwise direction moments will be positive, anti-clockwise direction will be negative. And by this figure 37, so in the case of hogging, okay, so from left to right hand side, so if you move, then all the anti-clockwise will be positive. Okay, so this is anti-clockwise, so will be positive moments and all the clockwise moments will be the negative moments. That is the reverse of this convention, okay, sign convention. So now you may think that these things are a little bit difficult, but when you will be solving the problems, okay, so then it will be quite easier to you. Okay, so don't be worry, okay, about that. So we'll be solving some problems later, then it will be clear to you. Okay, so thank you for watching, and we will be starting the next topic very soon. Okay, thank you.